Hello, welcome to my channel. Today let's solve another Leetcode problem, 370, reads addition. So we are giving a less, it is 5. Initially, this less will be zeros inside the length inside the array. Now we have an update. This update means inside there's a start index and add index, and this is the value. It will be plus. For example, from 1 to 3, from index 1 to index 3, we need to plus 2. So here will be 2, 2, and 2. And here, from index 2 to index 4, we need to plus 3. This means from here, we need to plus 3, it is 5. And here it's 5. And here it is 3. And the last step is 0, 2, minus 2. So from index 0 to 2, we need to minus 2. So here minus 2 becomes minus 2. Here is 0, and here is 3. And finally, we're going to return this array. So for such a problem, if we use brute force, basically we need basically we need, for example, we have how many numbers? Let's check. Let's check the range. So for this start and end, if it is let's check the numbers. So the numbers should be very big. As you can see, the start and end index should be less than the array. So let's say the length of the array is n. So here, this operation, how many updates, it should be n. Let's say the length of the updates. So there are the updates less, let's say it is m, and the range is n. So in total, there are m times n operations. N can be 10 to the power of 5, and m can be 10 to the power of 4. It means in total, it will be 10 to the power of 9. It is very big. So for such problem, normally we will use difference algorithm in an array. Normally, if we use brute force, we need a lot of calculations. But if we use difference, we just need to use on plus k time complexity. Let me explain it in whiteboard first, and then go to the code editor to finish the coding. Now let's see an example. Here we have our initial array. It is 0, 0, 0, and 0. So for the difference algorithm, we will calculate like this. So here, from index 1 to index 3, we need to plus 2. But for the difference algorithm, from the index 1, we're going to give a 2. So here will be 2. Let me put it here. So from 0, 0, and we have 5 zeros. And now from index 1, we're going to give a 2. So this one will be 2. So from here, this one will become 2. At index 3, we have another 2. But we will put it at index 4. It means index I plus 1, 3 plus 1. It is the index 4. Now let me put it at index 4. So here will be a minus 2. Why? Let me explain. Because we're going to plus the value in a range from index 1 to index 3. If we use a difference algorithm, we just need to prepare two indexes. The first index, it is the index 1, we're going to give a 2, and the last index plus 1, we give a minus 2. If we accumulate these values like this, so 0 plus 2, it is 2, the first value is 0, and then from here, 0 plus 2, it is 2, and from here, 0 plus this 2, it is 2, and from here, minus 2 plus 2, it is 0. As you can see it, if we use a difference algorithm, if we finish our first loop to find the start index and add index inside the array, and for the second loop, we just need to, for the second loop, we just need to accumulate the values, like this value plus this one, this value plus this one, this value plus this one. It's similar like dynamic programming, but it's a different algorithm. So as you can see from here, if the length of the array is n, so here it only for the second loop takes on time. So this is on. And from here, it always depended on the rate of the array. But if the length of the update array is m, so here it becomes on plus m. As you can see, before it is m times n, now it becomes on plus m. So the speed increased to linear. Yeah, so that is why it is much faster. Now, but for our problems, as you can see, we're gonna have an index plus 1. What about we have a range here? Index plus 1 will be here. It will be out of the range. But for us, we can prepare the array to be length plus 1. We give a length plus 1 here. We have another 0. Here we have another 0. So here we have another 0. So like this, we will not have the index go out of the range. Yeah, so we can solve the problem. Finally, we just need to return without this index, just return what left behind this array. Now let me go to the code editor to finish the coding. As I said, this is a difference algorithm. Normally, we just need to prepare a function. So this function will be 0, like dynamic programming, plus the length of the array plus 1, because we need to have a padding. Actually, this is just for calculation. After that, we will not use this one. Finally, we're gonna return f minus 1 because we don't need the last index. This is just for our calculation. Now we just need to finish the checking for the start index and add index. Finish update the array. It should be easier. For start, add, and increase inside the updates array. So the start will be plus, let's prepare the f start, should plus the increase. Why? Because if we have the first step, we have an index 1, 2, 3, we will plus 2. If we have another 1, 3, and 2, so we need to plus this increased value plus this 2, so it means it will be doubled. So this means y. And here similarly we need to decrease for the add plus 1. So here the add index plus 1 should minus this inc. This means it's just a value, increase value. Now we finished our first loop. Then we just need to finish the second loop. So for the second loop, it is for I in range from the index 1 to length of the array. Now it is f. What we should do, we just need to finish our accumulation of the numbers. So the fi should plus equal to fi minus 1. Now we just need to return f to the minus 1 because we don't need the last index. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. And for such range addition problems, it is a very typical problem use difference algorithms in a 1D array. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.